So I want to introduce the customer where I am. It's called EDSN, Energie Data Services Nederland. And they play a central role in the energy market of the Netherlands. Because in 1996, the energy market was liberated. And before that, you had these big companies who did the production, the transport, and actually the supplying, so selling it to like users of electricity and gas like us. So what that led to is that these three roles got split up. So now we have some companies who do production and transport, others just sell to customers. And you can imagine that this is quite interesting when you, for example, want to move. Because when you move, your physical like metering point where your electricity is coming from changes, but your contract you have with your energy supplier, you take it with you. So to facilitate all these processes, all the big grid operators like Enexis, Alliander, Stedin, and well, some more, they formed together. They formed EDSN, and EDSN it has the task to facilitate the IT between like all the a lot of parties in the Netherlands, not just grid operators, but energy suppliers, people who like organizations who are in some way involved in the market of the energy, so gas and electricity. So we have grid operators. They actually also are stakeholders and shareholders, like they pay for EDSN. There's the energy market with suppliers and sellers actually to customers of energy. And EDSN also like has a lot of relationship with different IT partners to build all the different, all the infrastructure and all IT basically. So it's quite a new organization, and their goal is to enable agile application development. Because just like so many other organizations, they really like come from a traditional waterfall organization, and they really want to become more agile basically. And they have a big Oracle system. CAR, for those of you who are in the energy market, in the energy sector in the Netherlands, it's like the registration of all the metering points and like basically the bookkeeping. But adding new features takes way too long. The system is already bloated with features, which are out of initial scope, so they just get adding things. So, and for some queries, some parts, it's just simply reaching its performance limits. So what they actually need is an environment to create new applications, which are more loosely coupled, and the microservice architecture we all know and love. New applications need to be scalable. There's one problem, is that often these applications, they need data from the legacy system. So this new application, they have to use the Oracle database data. So one way to solve this is change data capture, because it allows you to actually stream the data from the database in real time. And there's a Wikipedia definition for you right here. In databases, change data capture is a set of software design patterns used to determine and track the data that is changed, so that action can be taken using the changed data. So you don't want to keep sending dumps. I mean, you can send on dumps, which is also what we do in big data and analytics, do it daily. But having a daily dump is not always enough, especially if you want to interact with an application. It's weird for a customer if it types in something in an application and the data doesn't update in another place. So we want to have changes in real time. So historically there have been a lot of ways to solve this. You can imagine that you can keep track of some like date modified field and then just query your database for all the latest records, which is a solution. You can do it based on triggers. So this involves like creating database triggers in the database, keeping track of shadow tables, which update when the normal table is updated. Not really that convenient. It's a lot of work to update these triggers. You can also imagine that you just do a diff, so you have your new copy, so to say. You just check what is the difference between the database. But that is really expensive since you have to compare the whole table to the whole other table. Which brings us to the last one. It's called log-based change data capture. And that is actually what we are using. And most change data capture systems these days are log-based change data capture. Not all of them. For example, Kafka Connect. A lot of people might know it from Confluent. It just uses a query, which is yeah, it's nice for if your system can handle that performance hit. But well, in our case, of the Oracle system, it was definitely not an option since it was already struggling under the load. So what happens if you have a normal application which talks to their database? What actually happens under the hood is that this database keeps a transaction log. It just appends all the operations, the updates, the deletes, invalidate records. It's a very technical, low-level way to guarantee ACID, for example, when the database crashes. But our luck is that it's already being maintained, so we don't have to write any new software. Basically, we can just read this transaction log. So our change data capture software will just apply some logic to send on useful information, and then we can stream our changes upstream. So in our case we use Kafka, but I think you have multiple output places. You can stream it directly to a new database or to a data lake or whatever. Well, in our case, this could really help us provide the legacy data to the upstream applications, which are new, agile, like microservices.
A question.
Yeah?
The transaction log, does it contain all the fields that you need?
Yes, it's everything, updates and everything. So it's literally insert this new record, insert this new record, okay, update that new record. It's not an SQL statement, but it's a binary format. Okay. But it's usually like internal for the database.
So you don't have to go back to the database to get the...
Usually the change data capture software knows how to talk to certain databases.
And how do you know that those two databases are still in sync?
You mean this one, these two? Well, this is just very tightly coupled. Okay. So it's it's just the way the database works under the hood. It's not something you have to do. It's already happening.
Kafka and the database.
Yeah, well, that's something. Well, I'm going to talk about that later a bit because we tested, of course, if it's working, if all the data is coming through. But so I'll explain that. More questions?
Is it reasonable to assume that CDC is basically a rewrite of a part of a database? Because to replay transaction log, you have to re-implement a significant part of a database.
Yeah, models.
It depends because, like for us, we just get AVRO or JSON. We just get the field names and the values. So we don't at this stage we just have JSON. We don't have the database anymore. And it's also you get all small tables, and so it's not really a database anymore.
You support update statements, right?
Yes.
So you have to update your Kafka stream too, or you just dump events into it?
It depends on what you want. Like sometimes an update is also just a new record that upstream applications can just subscribe to, and then when there's an update to a certain ID, they also update their internal database. But this also depends on what data transformation you will do between that. So yeah, log-based CDC uses existing mechanisms that normally enable the ACID properties of a database, and you can stream updates to other systems. And the advantage of this is that if you add a new table, for example, you don't have to program more stuff. You can just take existing data which is already on the disk of your database server and just send it over. So the questions you ask are valid, right? Because at this point we only have our source replicated, but we don't want to bother all our new fancy applications with the data schema and all the business logic of the traditional application. So The architecture that we propose is to, well, have a Kafka-based streaming platform. We keep the data in Kafka indefinitely, so infinite retention time, kind of like a Kappa architecture for those of you familiar with big data architectures. And we use AVRO, which is a proprietary tool to stream it out of the Oracle database. And one important thing is that we want to decouple the downstream applications from schema changes in the source, or we don't want to have a replica of the database, basically. So the thing we want to propose, and this is all with dummy objects, but so say we have a source database with our change data capture software. We have a customer table, we have an address table, an order table, and an order line table. This is just the raw data, basically. And here's the domain layer. So this is actually also with cooperation with the architects of ADSN, like what is actually how we see a customer or some other business object. It is not this structure replicated, but it is a useful, future-proof representation with the best knowledge, of course. So then we have a customer object. In this example, for example, just with the address denormalized and added, also order lines added. And then here you must think we have like 13 or 15 different objects. And different application can have different needs, right? So for example, we might have our delivery service, which has an order and an address, which comes from both these domains. And so you create an outgoing topic basically containing the relevant data for an application. They can reuse them, of course, and but that's basically the idea. And also, for example, we have a microservice which keeps track of loyalty points. So we can have a customer revenue topic which has the revenue per customer. So the microservice can calculate how many loyalty points they get. And maybe publish data back. So this is the conceptual idea we had. So if you have this kind of structure, you decouple the source from the consuming applications, and you can also migrate away part of the legacy system, because you can just change this and this transformation without bothering all the upstream applications with that. So this is the idea. We were currently in the project. We are experimenting with the reliability and high availability of the HVR software. So here is our current application architecture. On the left you have sources, so everything that publishes data, and on the right we have consumers of data. So here in the top left we see the legacy system. At this moment we're not using HVR in production yet, but so it's a daily extract. We're going to move to HVR, of course. And here we have some processing going on. They used to use NiFi, don't ask me why, but actually it's still there for our current version. We're moving away to Kafka streams, which we're also using, because a lot of these topics, they are just filtered on some fields, and that's basically it. So, so some applications, they can also produce data again. So this is our current state. We have some audit service to check basically, like, is the data matching? Like, aren't we losing anything here in the processing part? So this is the current stage without CDC. So we have the technology stack we're using now for the ingestion is a CSV extract and a Java app which reads it in. But we want to move to HVR to get all the real-time updates we've been talking about. And for the processing now, we use NiFi, but we're going to move away from that. And use some other processing framework like Kafka Streams. And all the applications, well, they run on Kubernetes and with Java and Angular. It's not where I'm working, but something interesting is we have a tester, and what he had was a tool to basically get a CSV out of a topic. So always when he was testing our new functionality, he had to go on the command line, do some grep magic and test our application, which is not really that user-friendly. So with this... it's
automation friendly, which is good.
Yes, it's not automated. It's not automated yet. Yeah. Well, actually, we're moving to use Pyspark and Jupyter Hub in AWS Hadoop EMR installation, because we can just look a little bit more in detail to see actually all the columns where they're matching and do some more processing. So that's actually what I'm going to talk about, because this is all a work in progress, and where I've been working on the last months is actually like testing HVR and making audits, like using notebooks to basically compare our existing stack with the new stack. And to do that...
But how long you intend to keep parallel stacks? Or you want to switch like?
Like we're doing, actually we're going to do a production like load test in September with HVR, and then maybe like, yeah, we want to phase out the CSV, yeah.
So why I asked, because if you test manually 2 stacks, then it seems like you're thinking, okay, we do the switch, and this testing is not going to be automated and not needed because of the switch.
No, our applications
you will have parallel stacks for a while, then you might need this automated testing instead of manual.
Well, I mean, we have automated tests, but this is more for like testing Kafka, like what happens if I shut down a broker or stuff like that. So it's more platform testing than actually application, because for the application we have unit tests and integration tests and all that. But our tester likes to destroy things and like shut down random servers to see what's happened. And for that, we're gonna give him some more tools to do his work, actually. Otherwise, he has to write a script for everything. Well, a custom script for every thing he wants to do. And yeah, we believe that using a notebook is much better documented, much more better readable for like non-technical people as well, if you make them well. So I've been working with EMR to compare these things, and now I want to be a little bit more. This was all just a little bit architecture. Now I want to get a little bit more into Spark and Kafka, because we needed to test the HVR. We wanted to know, like, is the data transfer complete? Like, don't we miss records? And it's without corruption. So we want to be sure that all the fields are intact, and yeah. Basically to see if HVR is a good solution for us. And well, Spark integrates well with Kafka, and a notebook is a very nice way to have ad hoc analysis on something like, hey, we have this new topic and we have some new data stream, do they match? And if not, what is actually not matching? So one problem with change data capture is that you really get low-level data. So this is the 3-tier architecture a lot of applications use, and actually you're getting technical data from the database server. The user sends, of course, a request. Some business logic is applied in the application layer, and actually what you're getting out of here, you're not sure if you have all the business logic in there. So in our case, it was very well documented. There was a lot of knowledge about the system, and the system was very it had an audit log for everything. So we had everything in the database, which is a good thing. But I can imagine that if you don't really have a good knowledge about the source system, that it gets a lot harder. Because to give you an example, we're going to go from around 50 tables. We want to get them into like 13 or 12. Base Kafka topics. So yeah, you can imagine how nitty-gritty work that is. So in some cases it might be better if you can change the legacy application to publish an event to Kafka in that place. But that said, like that's not an option in our case, so we're still gonna try that. So our idea was we're actually querying the data now for a dump, a daily dump, and actually that's also what we're gonna do to make the comparison. So we have an incoming topic. We can export a CSV from a table, and we compare them in a notebook to see if all the records are there, basically. So sounds easy, right? Well, it was not that hard, but it was a little bit tricky because we are using Confluent AVRO. And who has worked with AVRO or heard from it? Yeah, okay. So for those of you who don't know it, AVRO is a binary file format with a header containing the schema in JSON normally, like this. So here's a record, user record with 3 fields and their types. And after that is one or more data blocks. And you need the schema to read and deserialize the data, basically. This works well for a file, but Confluent AVRO is... Confluent also wanted to use AVRO because it's more compact than JSON, then deserialization and serialization is fast compared to some other compressed data formats. And their standard says that you have 1 record per message. And because it's very wasteful to keep the entire schema in the message, they encode the schema basically, and they put it in front of the message. And so this is a picture from Confluent. So here we have Kafka, and we have producers of data and consumers of data. Producers, they generate a schema based on the structure, and if it doesn't exist yet, they submit it to the schema registry, and they prepend the ID of the schema, which they get from the schema registry to the data. This gets published to Kafka in a binary format, and then the consumer can read the message and then get the ID, the schema belonging to a certain ID, and then serialize it. But yeah, so this is a little bit, this standard is a little bit different from the normal AVRO standard. So Pyspark has some from AVRO or to AVRO functions, but they're mainly like built for the file format and not for the Confluent format. So and in Pyspark, which we are using, there's no function for this. So that was a little bit of a struggle, but normally you could just like select a column from your data frame, give the schema as JSON, which seems weird, but because in the Confluent format you could, in theory, just get the schema from the message. But yeah, this is not supported.
So why did you do it? Confluent
because it's in we use AVRO because it's generally a good idea if you're using Kafka to use AVRO because it's fast and it's. I understand that, but why is it Confluent AVRO? Because it's faster than JSON, much faster than JSON.
That was a requirement.
Yeah, it helps them if you have a very high throughput system where speed is very important because that's what they're creating actually. Very low latency stuff, like every millisecond counts. So. So at first I thought a Python UDF, like don't shoot me, but I mean I was just prototyping, but like it worked. Okay, so just for those of you who have, I'll walk you through it. So we want to cache the schema registry basically. This little trick makes sure that the schema registry object is actually instantiated on all the executors, because you need it in every process basically. So here we use the Confluent Python library in a Python UDF. So like, you can expect that this does not perform very well, and for some small quantity of data it worked, but Yeah, serialization of 150k records took 12 minutes with like 2 nodes with 4 cores and 16 gigs of RAM or something. So it's like, yeah. But yeah, so that was not an option. So yeah, we use the Scala UDF. Yeah, because if you use Scala, for those of you who don't know why Python UDFs are bad, I will explain it. Because normally in Spark, all the data stays in the JVM, and if you do operations through Pyspark, it just translates them to operations within the JVM. But if you do a Python lambda function or any kind of function on it, it has to leave the JVM, enter the Python domain, and then this is very inefficient. And then afterwards, Python in itself is much less efficient than JVM-based languages. So then afterwards, it has to go back. So it's very inefficient in general. So
why do you serialize and not deserialize? It's not a deserialization process.
Oh, well, this is an example. I started with reading the data to make this comparison. I mean, I'm at this moment working also to create functions to write data. So it's.
It was just a test.
Yeah, it was just a test, and it's just to show. I mean, the functions work similar. So. So we use a Scala UDF. So there's a library by some organization or group of people. It is an AVRO bridge for Spark, and you can you have to supply some config in a Scala map, and then you can call these from confluent AVRO functions with a column, and then you will get your data in Spark with the Spark schema in the schema already in place, etc. So that's quite nice, but yeah, then we have to call this actually from Pyspark. And if you ever tried this, it's quite annoying because if you make a mistake, you just get an error which does not mean anything. It's like a Py4j gateway something. So it's really yeah, but luckily it's like some other people, they were messing around with it, so I was not the only one. And actually what the result was, if the batteries are. So in the end, this is what you can translate it to. Through the Spark session, we can actually get the JVM as a sort of variable. So that's what I do here. And this is the package name of the Java or Scala package I actually put on my cluster and put it in the Spark submit for the initialization step. And well, here's some data it needs. It needs a schema registry URLs, a topic, some naming scheme. I don't know why it needs all that if you can just use the idea, but okay. I didn't want to write my own whole Scala library, so calling an existing one was good enough for now. And so this is just some weird code to create actually a Scala map in Python, and yeah, I'll just loop over this dictionary to basically recreate these things, which is the argument of the. Because a string or an int, like a low-level type, you can just pass, but these higher-level objects you need to translate. And this works, so you can have your new column, your value column, and yeah, this call has to be in here. But you can select this column, and then this actually works quite well because, ta-da, we have some results. And who wants to guess how long this one took?
2 minutes.
2 minutes? Any other guess?
About 100k seconds usually the number, right?
Sorry?
About 100k rows per second is usually the number, right?
I mean, depends, I guess, but 27?
20 seconds.
20 seconds.
2 seconds.
2?
No.
Okay.
Well, that's a minute.
All right, so we can hear the answer now. It was around 10 seconds, actually. if I remember correctly. I don't have it's a very scientific benchmark here, but it does really, it does like multiple orders of magnitude faster, which was like expectable.
How wide is your row?
Sorry?
How wide are your rows? How many columns are we talking?
20, 30, something like that.
Okay.
Yeah. So is that do you think it's fast or it's slow or?
I obviously don't know your data.
Yeah.
It feels slow to me, but I mean, listen to me.
All right. Yeah. So my conclusion, like I fiddled around with this quite a bit, and also because I could go, I could write Scala, but the tester I was helping actually, like it was a good step for him to start with Python. So this is a nice way to keep it in Jupyter and like call Scala under the hood, which was I thought it was quite nice. But like support for Confluent, AVRO, and Pyspark could be better because yeah, the AVRO functions in Scala, Pyspark, they only support AVRO files at this moment. And automatic integration with the schema registry could also be nice, but I think these two open source projects, they're pointing to each other like, yeah, if you want to integrate with me, you should make the effort. So yeah, I know that Databricks has it, but yeah, that's proprietary, so. Yeah, so in conclusion, like change data capture is like a really efficient way to stream data out of your legacy system or any system. And also, if you do that, you can, you can step by step migrate away this legacy system while still using it. It's quite a powerful thing. Might not be something that a lot of our analytics, big data people are into, but I think it has quite some potential. But the data generated by CDC is quite fragmented and low level, so if you have any other option to do it on an application level where you can just get some events, that's preferable. And if you do it, the knowledge about the source system is very important because you get a lot of updates, like after update, like there's database triggers and a whole complex system, and if you don't know what's happening there, then you're lost. So thank you for your attention. And are there questions?